Hello, in this video we're going to answer the question of what kind of structural features of a molecule can we make via an aldol reaction, or to put it in another way, how is an aldol reaction useful for organic synthesis? Okay, and what we're looking for is two types of structural features in our molecule. If you have a molecule such as this one, where you have a beta hydroxy aldehyde or ketone, that could be made via an aldol condensation, or an aldol reaction. So beta hydroxy carbonyl. Okay. Another type of compound that could be made is an alpha beta unsaturated carbonyl. Alpha comma beta unsaturated carbonyl. Okay, so this we would derive from a beta hydroxycarbonyl if we did a dehydration, okay, which we saw in a previous video. So if you see these kind of structural features in a molecule and you're asked to synthesize that molecule, then you should be thinking about how an aldol condensation could have made those. Okay. Now, to figure out what compounds could be used to make this in an aldol condensation, here's what we want to do. So for the beta hydroxycarbonyl, the carbon that's made is the carbon between the alpha carbon and the beta carbon. So we can kind of put a little squiggly line there to signify that this was the bond that was made. And then we've got this arrow, and this is a little bit different from other arrows we've seen. We might call this a retrosynthesis arrow. And here what we're doing is we're saying this could be made from these other molecules. Okay? So in the beta hydroxycarbonyl, that would have come from this aldehyde, okay, and this aldehyde, okay. And so the way that works, if we look at this compound, the half of the molecule that has the carbonyl is going to be the half that was used to make an enolate, and the half that has the hydroxy group is going to be the half that came from our electrophile. Okay, that's how we kind of think about that. All right, we can do some similar analysis for an alpha beta unsaturated carbonyl. Again, the new carbon-carbon bond is between the alpha and the beta carbon. All right, and so again, this part that has the intact carbonyl in it is going to be the one that forms the enolate in the aldol reaction. Okay? And then the other half, which does not have any oxygen atoms here, is going to be the one that was the electrophile. So we're going to basically replace this whole half with an oxygen atom. Ooh. Let me erase that. Okay, and so you can see here we have two molecules of propanaldehyde, or propionaldehyde, that we reacted with each other to form this alpha beta unsaturated carbonyl. Okay, let me give you one more example that could have been made by an aldol cyclization. Okay, so let's say we had this ring. Okay. All right. So here we've got carbonyl carbon, an alpha beta carbon. You can see we have an alpha beta unsaturated ketone. So this gives us a hint that maybe an aldol reaction could have been used to make this, to synthesize this. Okay, so we're going to apply the process that we talked about a minute ago. We're going to cut that in half. We're going to draw our retrosynthesis arrow here. All right. And remember that the half of this that has the carbonyl is going to be the half that was used to make the enolate. Okay. All right, and then the other half is going to be the one that has, that was the electrophilic part of the molecule. And so we're going to replace this carbon basically with an oxygen. Okay, and so just to keep track of things, I'm going to number these carbons 1, 2, 3, 4, 5, 6. And this could have come from 1, 2, 3, 4, 5, 6. Okay, and so that's going to conclude our lecture on synthesis via aldol reactions. And in our next video, we're going to move on to a new class of reactions called Claisen